Hey, good morning, everybody. Thanks so much for tuning in. Rob here from the Digital Arts Experience for another Create and Hang. Today, I'm continuing on my quest to master Fusion 360. Well, master may be a strong word, but explore a little bit more, deeper exploration into Fusion 360. Let's put it that way. So, hope everyone's weekend was great. Hope your week's off to a good start. I always look forward to Tuesday mornings hanging with everybody and working on something. I today am going to be putting some final touches on the piston mechanism that I had finished last week on Thursday. Now, if you haven't been tuning in and keeping track of my progress, I had started my Create and Hang series making functional objects. Like I had worked on a clamp that goes around a monitor stand that I have on my desk to hold one of my webcams so I can move and articulate it in a little bit more detail. That I finished, came out very nice. That was sort of the project that had me understand hinges a little bit, or how to model hinges a little bit better. I obviously understood the mechanics of how hinges worked, but the trial and error of trying to put that project together really helped solidify at least what I am calling my signature design of making hinges, which uses this pin mechanism that works together. It works great. Here's a version of the clamp, by the way. It's got a very nice working hinge here and here, which are all made from 3D printed parts, no external parts. So that was one object. In addition to that, I had made the other end that the webcam sits in, and from there I had changed my focus a little bit on trying to model assemblies, things with moving parts, not necessarily complex, but just to experiment with different mechanisms that have different components working together. And the first that I had tried was basically a box with a hinged lid and a lever on a linkage that will open when you pull the lever. So we've got a series of hinges, and the linkage connects to the box. I thought this was came out very nice. I was very pleased with this. This also was a very, very good learning experience. From there, I wanted to attempt to make a piston design where you turn a crank and it has a piston articulate in a receiving tube, which you can see I have modeled. I did that on Thursday. This was my 5th attempt at making this because I didn't thoroughly think through the design when I went into creating it, and as a result, it didn't work. There were some design flaws. But as you can see, I have managed to finish this. It's probably not the most efficient design, but, all in all, I think this came out pretty nice. Essentially, we have a wheel with a crank, which is connected to the wheel on the other side. You'll notice there is a spacer on the inside, and that will allow for the pin to hold the hinge on the linkage together. And I could have modeled the linkage a little bit more efficiently now that I'm looking at it, but this obviously won't. This clearance for this pin on the other side. This linkage arm has a hinge here, which connects to, and I'm just going to quickly shut off the base. This connects to a simple little piston, which has a hinge on its base, which connects to the linkage arm. And the tube that the piston is sitting in is, if I'm not mistaken, 25 millimeters in diameter. It's actually 50. Because the diameter of our circle is 50 millimeters. And while that's not exact because the linkage is set farther back from the edge, it'll be slightly off. When this crank turns a full 180 degrees to here, that will mean that the piston will slide back to the far end of this receiving tube. And when it comes back around, the piston will push back up to the top. So very simple piston mechanism. I am pretty happy with the way that this came out. In looking at it, I probably could have perfected a few things and thought through some details a little bit more thoroughly. But, I think this is pretty good. And I think, after today, I'm going to say that this project is done because I've tortured you all long enough with trying to find my way through this. So what I'd like to do today to start with is I want to see if we can get some movement in this. As I had mentioned previously, I found a great YouTube channel, Lars Christensen, who's a CAD designer, CAD CAM designer, and had a couple of great videos on how to deal with bodies versus components and hinges and how to make things move and simulate their movement. I found that to be immensely helpful. Lars's his way of explaining things is very thorough and really helped me understand. So I think I'd like to apply that to this design. I have some things I don't know how they're going to work. We're going to do a little experimentation. Going to be a little trial and error today. You know, we'll probably spend half the time or a little bit more on that. And I think the next project I'd like to work on is to start to explore creating some gears and some mechanism that requires gears of different ratios. I don't know what that is exactly, but I think if we finish our hinges and movements or the joints and movements in this model, I think I'll start to experiment with how to simply model gears. I think we can do that pretty easily with the circular pattern tool, but we'll figure that out when the time comes. So I'm not necessarily going to make anything in detail with gears today. I'm really just going to experiment a little bit. That's pretty much going to be the gist of it. So before we get started, real quick, again, thank you to Lars Christensen. I will put a link to his YouTube channel in the description when I'm done with this live stream. The other thing is, of course, I've got Wolf and Raven on again because they are my favorite synthwave band. And I will put a link to their album, Wolf and Raven. Thanks so much for the awesome music. And of course, hit the subscribe button if you like hanging out with me and working on these projects and all the other great content that we put out on our YouTube channel. By all means, please hit subscribe. Really appreciate it. Throw a comment if you like what we're doing. Give it a thumbs up. If you don't like it, give it a thumbs down. All good either way. But anyway, let's get started and get this set up. So just to give you some setup here, I had modeled this with every component set up in their own, with every piece set up in their own components. So that's what this cube signifies here on the left, is this is a component. Our top level here is an assembly. You can see it's a series of components stacked up. And then every set of, component of this, or every feature of this model is its own component. And you can see I've separated them all out by what I think needs to be separate groups. Now, of course, we can group these together when we go to make the joints, but this is going to make our lives easier. And just quickly to recap from last time, a component, if we open this up, has its own set of origins, bodies, sketches, and constructions, which is nice. So all of the things that are required to make a component are stored within it, which is great. One of the challenges I've run into in the past is if you sketch something, turn it into a body, and then turn the body into the component, the sketches don't move over into the component. They stay external. So when you're modeling something in Fusion 360 and you want to have things move and you need to use components, you want to set those components up and label them ahead of time, because that way all of the stuff that's required to make that component is contained within it and not separate. The other thing that's nice is each component, when you activate it, has its own timeline. Obviously, we see the full timeline down here in the assembly, but each component, if I select one of them, now you can see its timeline has changed to make up the steps required to make that component. So anyway, after I had spent some time studying the way you would create an assembly and make things move in Lars's videos, I now have a pretty good idea of how to get started. And the first thing we need to do is we need to ground a component that's not going to move, so it's fixed in space, and from there we can then build our assembly. So the first thing we're going to do is we're going to ground the base, because the base is never going to move. Our base, if I shut everything else off, is simply the receiving tube and this little arm to hold the crank. So let's go ahead and ground that. We're going to do that by right-clicking on the base and selecting ground, and now there's a pin icon in this base. Okay. The next thing I think we'll do is I'm going to shut off the linkage and the pins. And then we are going to create the circular movement of the crank. So let's get rid of the linkage. And I think actually I can make a rigid group of the pin, and I don't even think I need to do that. Well, maybe let's do that. So I've got this pin here, No, see, I can't make a rigid group with the base because some of those pins are going to move. So what I really should have done is made the pin separate components. I'm going to ignore them and see what happens. What we'll end up doing... Oh, man, I realized I'm probably going to have a problem with these pins because these pins need to move and this pin doesn't. And these are all one component. If you take a look, if I move these, see, they're all one component. So I think I'm going to have a problem with that, and I'm not going to go ahead and remodel them and separate them all out. I think what I'll end up doing is just shutting them off so they're not visible. Mistake on my part. I should have had a section of static pins and moving pins. My mistake, and that's fine. So for now, we're going to shut the pins off. So the very first thing I think we'll do is let's get these items set up with joints, and we will get them to move together in unison. So what I'm going to start with is the... Oh, so this is one unit. Again, I probably should have separated this out. So what we'll do then is if I move this out, what I'll need to figure out is the distance between this edge and this edge. So let's see if I can figure out what that is. Wow, I did not do this correctly at all. I should have had two separate components for these two cranks, components of the crank. Now, they are going to move together, so it's fine. But let's I think I can work around this. I don't think this is going to be too much of a challenge. So I think what I'd like to do is I'm going to actually just create a sketch for reference. So I'm going to sketch on the base here, and I'm just going to rotate this. I'm going to just draw a line to see if I can figure out where the edge of this and the edge of this is. So let's see if we can figure this out. So this to here is 6 millimeters. Okay, so that's great. So what I can do now is I can actually take this assembly and move this out. And basically what I'm going to do is I need to set the point in which the joints of these two items fit together. So what I'm going to do is I'm going to create a joint and offset at 6 millimeters. So the way we do that is we go to assembly and we're going to create a new joint origin. So kind of like when you offset a plane in the construct menu to create a new face to draw on when it's offset from the face of a body, we can do the same thing with the joint origin. So the one thing I need to make sure I do is select the base. And so I want to create a new joint origin, capture position. And what I'm going to do is I'm going to grab this and I'm going to move it out 6 millimeters. And it's going to be -6. Great. So what that means now is I should be able to create a joint from this to here, and it should work properly. So let's see if we can make that work. So what we're going to do is we're going to create a new joint, and we're going to grab this right here. So that's one joint. And you always want to grab the moving component first, and then the other component. Now, right now it bugs out because it's set up as a fixed joint, but we can change that by creating a revolute joint. And now this moves, right? And we want it to, let me see if we can, let's simulate that again, right? Great. And we're going to rotate it on the Z-axis, which is fine. We'll flip it. Nope, I don't want to flip it. That's great. So now I should be able to crank this in circles. I can actually grab the joint. No, I'm supposed to be able to grab this little joint here, but I can grab it by the handle. I can grab it from anywhere, spin it around. Obviously, the sketch is showing up there that I was using for reference in this base, so we need to shut those sketches off. Let's get these turned off because they're confusing. Oh, and I need to do the same thing on the crank. So let's go to the crank and shut the sketches off altogether. There we go. So now we have this nice rotating joint, right? Which is great. So let's set this to 0 degrees, and you can actually see there's a little measurement here that shows me where my position is. I want this to be 0 degrees because I now have to set the linkage arm up. So that works. The next thing I think I want to do is I want to create the motion of this. And I don't know exactly how I'm going to do that. But let's see what we can do. So I'm just going to put the link. Just save this really quick, and we're going to save it. I'm going to call it motion because now we know that motion's been included in this. So I I'm going to run into some challenges here. I can tell you that right away, but the crank moves. And so the next thing I want to do is I want to get the piston to move in relation to the crank. So I wonder if I need to make the linkage a fixed joint to this. I think that's probably what I have to do. So let's move this out and let's create the joint and see what happens. So we're going to create a new joint. And now these I did not model any tolerances. I just have this flush with the edge of my crank. So let's zoom out for a second here. All right, let's see what happens here. All right, so now I don't want this to spin. If I make it a fixed joint, rigid joint, what does that do? So if I hit OK and I spin this, so that's not what I want to happen. That's not what I want to happen. So I'm going to undo that. I think it needs to... I think I know what needs to happen. So let's create the joint again. We're going to have to experiment with the different joints. So we're going to grab this right here and this right here. And now we don't want that to be fixed. That's fixed. That's not good. So we don't want it to be revolute because then it's going to spin like this. We don't want it to slide because then it's going to spin like this. Cylindrical is like this, so that's not what we want. Pin slot, I feel like perhaps that's what we want. And we want it to slide on the Z-axis, and we want it to be able to rotate. That's not really it either. Planar, ball? Nope, that's not it. Planar? So what does that mean? Component moves along 2 axes. Component rotates around 1 axis and moves along a different axis. Revolute, rigid. That's going to spin. That's going to slide. That's going to go like axis. Nope. Nope. No. Custom. Alright, so can I select? No, that's not it. Axis Z, Y, X. Alright, so I don't think that's it. Maybe it's a rigid... I don't quite know. You know, maybe I ought to set this joint up first. Why don't we do that? So it's on this side. Okay. So let's set this joint up first. So I'll move this out. Assemble. Joint. Capture position. That's fine. So now this... we're going to grab that, and then we're going to grab that. And this is going to slide. This is not... So this, I think, is a little easier. This is going to slide. Nope. Nope. There we go. The thing is, I need them to work together. So, there we go. Okay. Wait. Hold on a minute. No, that's not it. That's not it. Well, what if we make the joints matched? Oh, I'm so confused. This is... I told you this was going to be confusing. I need to do a little bit more homework, I think. I don't quite know how to do this, but let's see if we put a motion link together. So if I grab this and this. Okay, so that's cool. So the idea being... No, see, that's... Okay. All right. Well, what if I put some restrictions on this? Okay, so let's try this. If I go to the crank and I put... Oh, no, I have to go to the joints. And I have the slider. And I put joint limits. So minimum is 0. The maximum is maybe negative 25. Nope. Let's undo that. So slider, edit joint limits. Minimum is going to be here. Maximum is going to be 50. Nope. 25. Nope. That's interesting. 50 would take us here. 40. That looks about right. Animate. Okay. Cool. So now if I... Okay. Huh. Alright, so I'm kind of headed in the right direction here, but that's going too far that way. Alright, let's just shut all these joints off. I'm going to undo all of this. I'm going to go back to just the Revolve thing. So I've got the Revolve thing here. So, this might be a futile effort today, but yeah, I don't know. I'm feeling like this might be a little bit of trouble. I don't really know what to do. I don't really know what to do here. I don't really know what to do. So I think I'm actually going to call it here because I don't really know. I think I'm just going to spend the rest of the hour just bumbling around. So I think let's make a new project and let's change gears a little bit here. So, and that was not a pun intended because we're going to look at gears. So I don't really know how to make a gear, but I think we can figure it out. I'm going to just quickly save this and we're going to call it gears. And I'm going to save it in my joints project. I think what I want to do to start with is just make 2 gears of different ratios. And I think what I can do is I can use the circular pattern to make the teeth all the way around. I don't know. Let's see what happens. And if that's a failure, I have a third plan, which is we're experimenting with some of the create tools, but let's see what happens. So let's start with making some components. So we're going to make a new empty component. We're going to call this gear 1. And there's our gear 1. And then we're going to make another component, empty, and we're going to call this gear 2. We'll start with 2 gears. So let's start with a single gear. Always make the components before you start sketching, so the sketches are included. All right, here we are. Let's grab a center diameter circle. Let's make it 100 millimeters, okay? Let's just make that nice and easy. Now, we need to make teeth. Now, I assume I can do that with just drawing a tooth, right? We'll draw a tooth and then see if we can make a circular pattern around it. So let's make the tooth come out this far. And we'll make it, let's see. Okay, so now I've got this, right? I don't know if that's the right size. I'm going to just experiment with this for now. And then we're going to grab that and do a circular pattern. And grab our axis. And then, or I have to grab the center point, is that it? So, objects, center point is going to be... No, cancel this. I think I selected too much stuff. So we'll grab this. We're going to go to our circular pattern. And now what we need to do is grab the center point. Objects, we're going to grab this. And the center point, of course, is going to be the middle point of our circle. And so now we need to make this, is it like 50? We need to make it. Let's keep going up until they're all flush with each other. All right. I mean, that looks pretty good. All right. Finish sketch. So now I have this. I don't know if that's the right way to do this. I really have no idea, but let's see what happens. Extrude, and we'll make this, I don't know, 10 millimeters high. Oh, my Fusion 360. I mean, that's a gear, I suppose, right? Small teeth. I mean, the one thing that's interesting is the fittings in here. See, it's got the... I wonder if I need to... Hold on, let's go back. I wonder if I need to sketch this another way. What if I need to... Huh. Oh, man, I don't know. Let's just take a look at what other tools we have. Now, I could use the... No, threading's not going to work. I must be the way to do it. So let's edit this sketch and try that again. I mean, edit sketch. All right, there's my tooth, right? Maybe I needed to make more teeth. So let's try this. Create circular pattern. That our center point is going to be here. And I think I had made like, oh, we'll do 120. All right, so now, let's see, I want, what if we did that? Okay. That looks pretty good. So now I think what I want to do is grab a center point circle and bring it to the edge of this. Okay. Uh-oh. Fusion 360 is about to crash. Oh my god, wow. I thought that was going to crash. Alright, so now... Wow, I don't know if I just have so much geometry in it that it's lagging, but man, Fusion 360 is not happy with me today, huh? Alright, so let's select everything. Wow, what is going on right now? This is interesting. I don't know if I just have too much going on, but it looks like Fusion 360 is a little overloaded. I don't know why. Okay, well that did something. Do I have to deselect all of these? Oh my god. Well, what if I did this? What if I erase this outer circle? Wow, this is so crazy. Why is this acting so... I mean, I've definitely made super complicated sketches before, but it's just totally overloaded. Oh, man. Okay. Okay. Alright, let's see if we can get this to work. Extrude. We will make this 10 millimeters. Alright, so... I mean, that's a gear, right? It's not a very nice one, but it's a gear. Okay. I would just need to make a hole in it. Let's make a hole in it. Alright, so we'll make a, 20 millimeter hole in it. Whatever. All right. Okay, so that's a gear, right? Very fine teeth, probably. Huh. You know what? Let's back out of this. Let's go back to the beginning here, undo everything. Let's start over here. I think I'm going to make fewer teeth. I just think it's too much. So 25 millimeter shape. And we need lines. And I think I want to put, I don't know, like 10 teeth around this. I don't know. So we'll have a point here. Right, and then have this. Huh. Gears, I don't know. I mean, I guess the gear I created was good, but it seemed like it really messed up the geometry in, yeah, it seems like it really messed up the geometry, or something. It's like Fusion 360 bugged out, so I don't know. I'm kind of bumbling around today. I don't really have an idea for a project as a result of this, so, well, let's do this. Let's make a new project. And let's experiment with some of these other create tools and see if we can get these to work properly, because that's something I've always wanted to do. I played with some of these, but all right, so we know what extrude does, right? It takes a sketch and extends it out. Fine. Revolve we've played with before, but let's experiment with that a little bit. So basically, what we're going to do is I'm going to create a circle of, let's say, 100 millimeters. Okay. And then what I'm going to do is I'm going to make a sketch on this plane, right? And what we're going to do is we are going to just kind of freehand draw something, right? We're going to grab this. And, wow, that's cool. Oh, I used the spline tool. I meant the line tool. Okay. So we grab this to here, to here, to here, to here. And then we'll kind of seal this off like this. Okay, so I made this shape, whatever. Okay, right? So I have these two sketches. All right, here we are. So the Revolve tool will take this shape. So we want this profile to revolve around a certain axis. And I want it to be this axis. And now, look at that awesome shape I just made, right? Super, super cool. Super cool. In fact, let's go back and let's edit this sketch. I'm going to go back for a sec. Yeah, good. Okay, we're going to see. So what we're going to do here is come to here, and then we're going to come to here. And then I'm going to actually... Oh, let me zoom in a little bit. Hold on, I messed something up. So let's go to here, to here, to here. And again, I'm just playing around here. I'm going to actually put some constraints on this too, which should be pretty cool. We're starting to learn about constraints. I don't have them all kind of figured out. I just started doing a tutorial yesterday on constraints. What is going on here? So this. That's fine, whatever. I'm just freehand sketching this nonsense. It's nothing. All right, good enough. All right, cool. So I want to actually put some constraints on this. So let's use the parallel constraint. So let's make this and this parallel. Cool. Let's make this and this parallel. Great. We'll make this and this parallel. Overly constrained. All right, so it already is powerful. So all right, fine. So that's it. So now this shape is wacky, right? If I grab this and I grab my Revolve tool and work around this axis, check out that pattern on the inside. How cool is that? I mean, imagine trying to model that without the Revolve tool. I mean, that is just so cool looking. Now we want to make it really cool. We could fill at these edges, round it off a little bit. Let's see. Oh, man. And we'll do this one, too. Wow, so cool. Let's shut the sketches off. So, obviously, you can make some pretty incredible shapes using that Revolve tool. So that's pretty cool. Let's put that to bed here, and let's check out the next one. So, sweep. So, sweeps a sketch or profile or planner face along a selected path. So, I think I know what that means. Let's make a sketch here, and we're going to do it off to the side. So, I'm going to start by making a spline, and great. Okay, perfect. All right, so there's my spline. All right, and now we're going to make a new sketch. Right? I'm going to make a sketch over here because that's the starting point of my spline. So I'm going to just grab the line tool, and I'm going to start from here, and I'm just going to draw a shape, okay? A finished sketch. So now I have this sketch, right? That's a weird shape, and then I've got the spline. So as I understand it, we can go to the sweep tool. The profile is going to be this, and the path is going to be this. And I guess body would intersect itself. Try reducing the taper angle. Okay, so I think I need to edit the spline a bit. Let's try that. Maybe the shape that I had, that spline that I had created was too crazy and the shape would intersect itself. So let's try that again. So we have here, this path, and then this one. Shape would intersect itself. Parallel. Oh, there we go. Wow, I don't know what just happened, but that's out of whack. Let's undo that, and I think maybe this angle is too steep, so let's bring this out like that. All right, so let's try it that way. So, sweep. Here's the shape. Here's the path. And we have ourselves a 3D form from that shape. So we can draw a shape and then have it follow a path, which is pretty cool. So it's kind of like the Revolve, but it doesn't have to be a complete circle. We could just choose a path instead of an axis. So very, very similar. So that's pretty cool. Let's check out the next one. So Loft, I absolutely love. Let's play with Loft. So Loft I've used before. So we're going to sketch over here. And I'm going to do this really easy. I'm going to start with a circle. And then what I'm going to do is I'm going to actually offset a plane up. Let's make it 50. And I'll sketch on this plane, right? I should be... Nope, I'm not sketching on the plane. I selected the wrong face, so let's do that again. All right, now I'm sketching on the plane. So now what we'll do is let's see if we can sort of freehand draw a shape here. Let's see if this will work. I don't know if the geometry is going to be too crazy, but so I've got these two shapes now. So what I should be able to do is grab the Loft tool, grab this. That's profile 1. That's profile 2. And we have made a 3D form that goes from the shape to the other shape and connects all of the axes, which is very, very cool. So the example that they show is going from a circle to a square, which is really cool. So awesome. So let's look at rib. So uses an open sketched curve to create a thin feature. The rib is created planar to the sketch plane. Select a curve and then specify the thickness. So I have no idea what that means, but let's see if we can recreate what's shown in the image. So what we'll do is we'll basically just kind of freehand draw a shape that looked like the shape there, right? Right. And then we will basically make this a 3D form. Let's bring it up, I don't know, 25, right? And now I think if I was to create a curve between these sections, let's grab a 3-point arc. We'll just go here to here and do that. Fine. Okay, so now if I grab the rib tool, this is my curve. Whoa. 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 What the heck? All right, cancel that. So, all right, let's try something here. I don't know what is happening. Let's push-pull this. Let's just cancel that, and we'll undo this. Undo, 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 undo. We'll push-pull this 30. All right. So if I offset a plane, -15, so that's dead center. And now I select this face, and I draw, let's just say, a line here to here. I'm just eyeballing this, right? And like to here and to here. So can I do this? Or does it need to be an arc? It needs to be a curve. No, it doesn't need to be a curve. Fail to create an edit curve or select another. Cancel. Okay. So it says I need a curve, but can I do it with just a line? Let's see what happens. So rib. Wow. Okay, so I don't really understand the application of that, and I don't know if I'm using it correctly. If anybody has an idea, throw it in the comments, because I'm not sure. That's a little confusing. I'm going to consult my friend Lars Christensen for that. So web uses an open sketch to create a thin feature. Yeah, I don't know about that. Coil, these, oh, so these create primitives. Okay. These I'm going to have to do a little bit more research on. Let's try the hole tool and see what happens. Hole. All right. So it basically allows me... Oh, this is cool. This is really cool. So I selected the face. I can move this wherever I want it. I can change the diameter of it. I can use a reference. I can change the hole type. A countersunk hole. Cool. Wow, cool. So that's cool. Simple hole, clearance hole, tapped hole. That's really awesome. So instead of having to... Wow, 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 wow. So, so instead of having to draw and thread a hole, we can do that all at once. Wow. That's really cool. And so now we've made a tapped hole in this. Oh, wow, and it's only tapped at the top and then clear on the bottom. Wow, that is fascinating. I didn't even know. So what I would normally do in that case is I would draw a circle, press it through, select the interface, and thread it. But wow, that's really cool. I actually didn't know that that even existed in here, so I'm learning something new. All right, well, that's awesome. So now let's take a look at some of the modify tools. I know this is not me actually making anything. I'm just sort of exploring Fusion 360, but I think I have a little homework to do before I can move on to the next project. So we know about fillet and chamfer. So let's talk about shell. So this is pretty cool. I can, I absolutely love this shape, by the way. I'm going to totally save this because that shape is amazing. Although I just labeled this Untitled, which is great. But anyway, let's create a sketch. And actually, I want to create a sketch here. All right, so let's make a shape. Let's just make a rectangle. All right, and then let's press pull this 50. So I should be able to select this face and select shell. And it should... Yep. All right, so it makes a shell on the inside, which is awesome. So if I was making a box, for example, this would be the way I would do that. I just noticed my view is really weird, so I just changed it to perspective with ortho faces. So very, very cool. So so that's awesome. So I can make a shape and just shell it out really quickly. So draft, let's see what draft does. Target. So plane, No, hold on, cancel. So let's take a look at what the draft. So plane and face. So the plane is going to be this, and the face is going to be this. Okay. Very, very nice. Okay, so that will let me take the plane as kind of the... so let's try this another one. Let's cancel that. Let's do that again. So we draft, and we'll grab this as the plane and this as the face. And now it should angle sort of around this edge. Yes. Whoa, that's really cool. That's really cool. That's cool that we can have this sort of angled notch here. I don't know where we would use that, but very, very cool. All right, so that's really awesome. Scale, just change the scale of it. Combine, we know what that does. Offset face. So check this out. If I offset face, I think I know what this does. So I could select this face and bring that in. Very, very cool, right? So if you look at the picture in that graphic, it's pulling that one side of the shape in, which is pretty cool. So it shifts the selected face or face in positive negative direction. You can do multiple faces or one at a time. Awesome. Replace face. Replaces one or more part faces with a different face. The new face must completely intersect with the part. So I guess if we were to draw a face that's curvy through the top of this, we could cut that. So split body we can take a look at. This one I learned, which is really cool, which is I can take a construct. Let's make an offset plane, right? And stick that over here. Now what I can do is I can go to split body. The body to split is this, and the splitting tool is my plane. And you can see I now have two separate bodies. And I can move them independently of each other. So that would be really useful with a clamp, right? So I could have made this a complete thing and just split it down the middle rather than making the two halves. That's a useful tool, right? If you have anything that's symmetrical, make the whole thing, split it in half, and then you're good to go. So let's take a look at an example of that, of how that would work. So let's make a new sketch. You know what? I'm going to make a new project because this is getting ridiculous. So let's see. I'm going to make a 50 millimeter thing here. And then I'm going to grab a rectangle and I'll do this with the line tool and basically do, whatever. We'll grab a rectangle and we'll just basically do like this. And same thing here. Whatever. I don't really care about the dimensions right now, right? And then basically we're going to grab... We'll take this. If you're zoomed too far out in Fusion, it gets a little cranky, right? And so now we can basically sketch the top of this. Let's see if this is going to work properly. Oops. Actually, I'll do it this way. We'll do the center point and do it like this. So we'll grab this basically. Obviously, this is way off, but I'm just doing this quickly for example's sake, right? And then I can pull this downwards. And then I can sketch on top of this again. And I'll grab my center point circle and basically make a circle like this, right? Finish sketch, and now I can take these and get rid of them. All right, now, so I have, let's say I want this to be two separate things, right? So I can take this and I can offset a plane, and I'm going to come in -15 because I made that 30 wide, I think. Oh, maybe not. All right, let's just call it that, right? So now I can split body, take the body, grab the cutting tool, okay, and now I've got these two separate bodies that are perfectly symmetrical, right? So for the clamp, Ah, see, that's really cool. That's very, very cool. They're two totally separate pieces, right? And I can move them independently of each other, right? So if I wanted to put a hinge on one side, I would know that that was totally, totally perfect. The other thing that I could do with that, oh, wow, is when making the hinge. Oh, let's take a look at this really quickly. Hold on a minute. Let's take a look at this. There's another way to use this to make a hinge. And then I think we'll wrap up for today. This was really helpful for me. I just have I got all these new ideas on how we might be able to model things. So I'm going to go ahead and model, I'm going to make a hinge, a really simple one, right? It's going to be sloppy. I really don't care. So let's make it 15, right? So we have that. And now we have basically, all right, cool. So all I'm going to do is I'm going to grab this and come basically to here, and then do the same thing on this side. Right, and do this. Right, so I now have this hinge. All right, so now we're going to hide these bodies, and I'm going to take this. I'm going to press pull it up 30, I think I said, right? All right, so, and then what we'll do is this is going to work great, I think. All right, so we take this, we grab our center point circle, and do 10, right, for the pins and all that jazz. So I take this, I press pull that down all the way through. All right, cool. So now, what I can do is I should be able to select this face, offset a plane down -15. Let's do 10. And then I'm going to do another one. Offset plane, -20. Right? Or -25. No, -20. Okay, so now what I should be able to do is I can split bodies. Oh man, I hope this works. Take this body, and the splitting tool is going to be this. Okay. Then I'll do the same thing here. Grab this body, right? Modify. Oh, I have it right here. Split body. Splitting tool is this. Okay. So now obviously I have no tolerances, but I don't care. So now all I need to do is I'm going to select. Let me hide the constructs for a second. I'm going to attach the top and bottom to this side and the other one to that side. So I'm going to basically grab this. No, other one. This and this and this. And I'm going to combine, join. Okay, so now that's a body. And now I'll do the same thing on the other side. Wow, I am so psyched about this. Join. Okay, so now that hinge I know is perfectly aligned, right? And so if I take this body and I move it out, wow, that's such a great way to make hinges. See? Look at that. Now, obviously this isn't modeled correctly. That's not right. But because if I was to rotate this out, it would interfere, and I need to cut some clearances and all that. But that's a really cool way to make sure that my hinges are perfectly aligned. Very cool, very cool, very cool. Yeah, there's some issues with this. I would need to shave off some material there, but that would be easy enough to do. I could basically sketch here and make a 3-point arc. You know, let's do this to like here, right? And anyway, I can pull this downwards now. I don't think that's exact, but it's good enough. It's kind of sloppy, so, but I could basically then cut this out, right? And now I know I have clearances on that side. I can do the same thing on the other side. Obviously, that's just a quick rush job, but Anyway, the idea of taking a solid cylinder and splitting the bodies up will ensure that it's perfectly aligned and everything's sized right. So that's really cool. So I think I'm going to wrap up for today. You know, I had very high hopes of getting the mechanics of the piston mechanism to work in Fusion. Obviously, that didn't work. I think the joints are just too complex for me to understand how to create the relationships between them. Because if you think about it, I need the crank to spin. I need the linkage on this end just to slide in and out. But on this end, it needs to follow the rotation of the circle. So I don't know. But we'll figure it out. At any rate, thank you for bearing with me today. Obviously, this was a little disorganized as far as my projects go. What I'd like to do for Thursday is I'm having some problems with my 3D printer. I'm going to get that tuned up, and I think what we'll do is we will print the piston, and maybe we'll assemble it. I'll set up a camera so we can look at the process of assembling it together and test out its parts. I should have modeled everything with the right tolerances, that everything should work properly. I also did notice I messed one thing up. With one of the pins on the linkage, they fuse together, and I need to split them. So I probably have to erase it and redo it. But that's totally fine. We'll fix that. But at any rate, thank you for bearing with me through this mess of a project today. But, you know, I learned something new. I think this idea of splitting bodies to make hinges is going to be excellent. So that was very valuable for me. So thank you for allowing me to discover that through failing a whole lot. But that's how we learn. But at any rate, thanks for tuning in. You know, if you like this, if you like the other content that you see on our channel, hit the subscribe button. We really, really appreciate it. It's really helpful for us, you know, especially through the challenges that we're facing with this pandemic. So, you know, it would really support the digital arts experience if you'd hit the subscribe button and watch a couple videos. You know, if you like this, give it a thumbs up. That would be great. If you didn't like it, give it a thumbs down. You won't hurt my feelings, and it'll help me make my projects a little bit more engaging. So hit that subscribe button and check out the DAE.com for our list of classes and private lessons. If you want to learn Fusion 360 with me, set up a lesson. I'm happy to take you through it. And I really appreciate you tuning in, and hope you all have a great day. Thank you.